I'm Dave Coulter, and this is the Lizard Brain Project. Joining me today is Amelia Weiss. She recently earned her PhD from Cornell in ecology and evolutionary biology. Amelia, thank you for taking the time to be here.
Sure, thanks for having me, Dave.
The focus of this interview series is about the disconnect between the fact that we are an intelligent, scientific species, and we have all the tools and all the data that we need to understand the mess that we're getting ourselves into as far as the climate goes. And yet, we're not willing to do what's necessary to fix it. It's that conundrum that this is really exploring. So, I've been trying to figure out how I wanted to start this with you. You're the first evolutionary biologist to join me. I keep coming back to the idea that the disconnect has to do with the respect that we have, or the lack of respect we have in our culture in general for science. We allow our elected representatives to get away with not incorporating science into most of their decision making. And so I guess I want to start with asking you what you make of that, the fact that we don't make science our go-to when we're trying to solve questions that are as important, for example, as climate.
So that's a great question. And I think what really gets to the heart of that is the fact that science has become politicized. So science is based on fact. It is based on, repeated observations of phenomena. And the whole principle is that you can have one research group in, one place of the country, study something, observe results, and draw a conclusion. And if another research group on the other side of the world were to repeat those procedures, they would find the same results. And so that's science.
It's completely objective.
Viewed as independent of, political ideology. But that's, in the last decade or so, that's really changed. And I think that's really what is at the heart of this, is because science has become viewed as this political, polarizing thing, then that's what allows people to say, oh, well, disregarding facts as opinions.
You go to a lot of conferences, and my guess is you can't put 10 biologists in a room without someone bringing up climate. At this point, is that something that's being talked about in the community?
We don't really talk about, is it being politicized? Because from our perspective, that is absolutely the case. There's a lot of conversations going on about what to do about it, and how, we as scientists should move forward in trying to bridge this gap, because scientists in the ivory tower were notoriously bad at communicating what we do to the general public. And, there's a lot of conversations going on about, to what extent scientists should be involved in advocacy, because that can be polarizing, and it can then be hard to draw the lines between fact-based science and, the political context or, ideological context that can then be involved when you're thinking about advocacy. And so there's a lot of conversations going on about how to deal with this.
Because the public will then lose their perspective of scientists being neutral arbiters of the truth if they're seen as advocates.
Right, exactly. But at the same time, historically scientists have, really shied away from that advocacy role. But given where we are now, it's clearly not working. So something needs to change, and we want to, science should be seen as independent of ideology. And so it's really a challenge to how we can get back to that without, exacerbating the problem that we're trying to rectify.
Right. But it wouldn't be happening if the public wasn't vulnerable to those politicizations in the first place, right? I mean, there's something about popular understanding of science, and this is a disconnect. I keep using that word, but I think it's really appropriate. That's part of this disconnect that is fundamental, I think, to how the public sees scientists and the role of science in general. I go back to, I had the privilege of seeing you publicly defend your dissertation. And it was a fascinating hour to be present for. And two things really struck me when I was there. One was, and it's the same thing that anytime I'm in contact with true professional high-level science, I have the same impression. It recalibrates my understanding of what you guys actually do, what science looks like in the professional realm, how granular it gets, how deep an individual line of study goes, and how narrow it can be into what it's looking into, and the relationship between that and the wider questions that it's asking. For example, you go deep in your dissertation. You were looking at very specific closed system nutritional dynamics, which had to do with adaptation, and that had to do with uh, specialization, evolution in general. So you were looking at something this small, which is a part of something this big, right? And so it always impresses me when I come into contact with actual professional level science. I don't know how else to call it as opposed to, what we learn in school. But the other thing that struck me was that anybody walking into that classroom off the general public would have no idea what you were talking about. I mean, I only understood the broad strokes. And I have a better understanding of science than most non-scientists. I think that's fair to say. And so I was following along in the broadly, but there's very specific language. There's very specific math. The math itself has very specific terminology to it that you really have to go that deep into it. And that to me is a big gulf. That's a big hurdle for the average person to breach, because what they're left with is what they understood from high school and middle school, right? And so that I keep coming back to that gulf as got to be part of the problem, why we're vulnerable to those sorts of manipulations, or vulnerable to someone telling us, that someone we trust saying that's not real. Like, they're wrong about that. The media is overhyping what the scientists actually think and that sort of thing.
Yeah, so you're absolutely right. And the language and the terminology that you touch on, I think, is a huge part of that, because you and I, we're speaking in English right now. We're speaking in the same language, but just because we're speaking in English doesn't necessarily mean we can really communicate in a way that will really understand what the other person is trying to convey. And in, scientific communication, like, the way that I would just, try to convey a scientific principle to a non-scientist is very, very, very different from the way that I would speak if I was talking to my colleagues. And so even if, both of those conversations were taking place in English, I could use the same words, but they would mean very different things. And I think you're absolutely right in that, there is so much debate about the nitty-gritty within the scientific community. I mean, you can pick any topic and there will be debate. But the level at which that debate is taking place, or the nature of what people are really trying to, figure out, it can be very difficult to communicate that to the public in a way that doesn't lose the bigger picture. So, we're talking about climate change in particular. If you put 10, climate scientists in a room, oh my gosh, we could come up with, there's no limit to the number of things we could find to debate about or disagree about. But that does not mean that group of people are going to, that does not mean that there would be disagreement about the fact that the climate is changing due to anthropogenic activities.
Yeah, and the core data is not in debate by any of them, and what that data means is not in debate.
Well, the bigger picture. So what, the way that we interpret data, there can absolutely be debate about, what this means or what that means. There could be vigorous debate about if we think a particular species of frog is likely to alter its geographical distribution in response to climate change, if it's likely to be able to accommodate the changing climate based on some data we have, or if we think it is very unlikely that this particular species of frog is going to be able to survive. That is not the same thing. Like that, there's tons of debate at that kind of a level, but that is not the same as saying, that doesn't mean there's debate that many species are going to be driven extinct due to anthropogenic activities.
So I had this thought earlier today when I was thinking through all of this, that the average person expects science or scientists to save them from things or to make things better. That it's not something that is, they're not part of the process, right? Like they And I think back to what are previous, there's not very many previous existential crises that humans have faced on a global level. There's not very many of them. And I keep hearing people say, well, we've come through existential crises before. And have we, though, really? I mean, and so I look back and so, okay, what went into those solutions? I think about the agricultural revolution of the 20th century. We were running out, projections were that we were not going to be able to feed all of the people in the world with the farming techniques that we had and all of the different tools that we had. So science solved that one. I mean, we through very scientific methods, we figured out how to get more crop yields out of the same field. We figured out how to make seeds that would grow in places where seeds hadn't grown before. And all of these things were scientific achievements that were huge success in solving that problem. The public had nothing to do with it. They just had to eat the food. There was no input required from the general public. The scientists figured that one out. And then I think, okay, well, so what's another example? But the only other truly existential crisis I can think of is nuclear weapons. So I'm thinking of the Cuban Missile Crisis. And that played out over less than 2 weeks. It was a political solution. It wasn't even a scientific solution. And the public literally could do nothing except sit in front of the televisions and wait and see what happened at the end. Are we going to have a catastrophic nuclear war and possibly kill everybody, or are we going to work it out? But it's in the realm of the politicians, not the public. So climate is something that we will not fix as a society, as a global community of Homo sapiens, without the public engaging in the science. They have to buy into the science in order, because we all have to be part of the solution. Government won't be the solution if the people aren't behind it, because as we've seen in this country, they're going to resist it if they don't think that it's real, if they're being convinced that it's not real. And so I think that's the tricky one. We've never been in that situation before.
Well, I mean, yes and no. I do think it ultimately is going to require political will. But the way that we achieve that is by electing people who buy into the idea that facts are facts, regardless of whether or not you choose to believe them. Fact is fact. And so I do think that to make the changes that need to be made to address the climate problem, those have to come from, those are going to require political solutions, because it's going to require really drastic changes.
They will. And grassroots is not going to solve this. But for example, I have a good friend of mine who, she's a very smart person. She is a professional. She is a senior person at a national bank. I mean, she's a very successful person, very easy to engage and talk to about complicated things. She grew up with her church and with her authority figures that she trusted throughout her life that tend very conservative. And she does not believe that this is a crisis. She does not personally believe that this merits massive government incentivization of, of changing how we make power, changing how we distribute power, changing how we make things, and all the rest of it. She simply doesn't believe it because the political leaders that she's been taught to trust are telling her that it's not real, that it's not necessary. The people at her church are telling her that it's not real or that it doesn't require that kind of thing. So it's not even, I mean, that's a grassroots problem before it even gets to the politicians, because her vote is going to be for the people who are taking political advantage from the fact that that belief in her can be reinforced by them telling, it's a pretty obvious cowardly path to power to be able to tell people things that probably aren't true, but it gets you elected.
Well, exactly. And I won't say this of all politicians, but I believe that there are many politicians who are aware of the severity of the climate crisis, who are, telling their constituents something different, because, the time scale, the time scale of turnover for politicians is so much shorter than the time scale over which, the consequences of climate change are really going to be felt. And so, it becomes this issue of, being aware of these long-term consequences, but there are so many, short-term, immediate there's this alternative short-term immediate gratification, being reelected by telling people what they want to hear. And so that's really challenging, because that means that we need people to act in a way that is against their immediate self-interest, which is a hard thing to do.
That's the real trick, is because that self-interest, that sense of self-interest, to me, that's evolutionary. I mean, that cuts back to before, it goes to the very heart of what we are as a thinking species. That we've got this drive that says if we can improve our quality of life, that is automatically registers in our brain as a positive thing. Like we're doing the right thing. Like that's what our brains are for. And we're asking ourselves to go against that.
But we're also a social species. And as a social species, we have evolved altruism, which means that, there is an evolutionary history of self-sacrifice to aid another.
On an individual level. But the question, I guess, is how does that translate to billions or even hundreds of millions in this country? Because at a certain point, it becomes abstract, right?
Absolutely.
So we can be, and I know plenty of people that I could describe that way that can be very altruistic in their community, but they don't see, but it's very easy for them not to see or be told that the science of this is in debate. So it doesn't require them to be altruistic on a larger scale, because it's too easy for us to convince ourselves that it's just not as bad as they're saying.
Right. Well, especially when, if you look out the window and it looks, when you look into your yard or look outside and it looks the way you think it should look. So there's a, disconnect between what people are being told versus what people are seeing.
Right.
And that makes it all the more abstract and hard to really internalize the gravity of what's going to happen.
That's a huge one. No question about it. You don't see it. It's so slow. And there's always been forest fires, and there's always been flooding, and the sea ice is always fluctuating every year. And so it's so easy to just instinctively feel like it can't be right. Even though that's the frustrating thing for me, is that science proves itself to those same people every single day. Every minute of every day, they are using things, they are walking on things, they are lifting things in their hands, which are the product of the successful application of peer-reviewed science. The devices that anyone is watching this on right now has hundreds of components, each of which is the successful application of peer-reviewed science. It works for them really well. The satellites that are sending this internet signal all over the globe, it's science. And so that's the maddening gulf to me, that you don't say, okay, so this process that science is defined by its process more than anything else clearly works very, very well. But I'm not going to believe it when it's a sunny day and they're telling me that the atmosphere is being compromised.
Well, the other thing that makes these examples, that's an additional challenge here, is you can see the computer in front of you. This is a concrete item that you can see as being the product of, countless hours and countless people, devoting their lives to different components and all of the engineering. But there's a concrete product that you can look at and hold. When it comes to climate change, it's sort of fundamentally different, because what we're really talking about is probabilities. And that's fundamentally much more abstract, because, we can't look at any single event. We can't look at any single hurricane, any single flood and say, this is because of climate change. That other flood wasn't, but this one is. It doesn't work that way. It's much more, I think the best analogy I've heard is that climate change is like having a weighted die. So it increases the frequency of these catastrophic events, but we can't point to any particular thing and say, this is a direct result of climate change, full stop.
Sure.
And that makes it so much harder, I think, to really, it makes it harder for people to grasp and for people to, really make the connections.
Right. So there's two different things happening that are working against us. One is our willingness to believe that it's happening because we can't see it and hear it with our own mammal senses. And then the other side of it is, if they are willing to consider that the scientists are right or take into account the voices of scientists. There are too many people who are being told the wrong information about what the science actually is. The voices of science are being misrepresented by the intermediaries and the media that they're choosing to watch, or the authority figures in their life that they trust who are choosing to tell them stuff that's wrong. And that part to me that's frustrating is, my go-to explanation for that is, you don't have to take anyone's word for it. You can go to the scientific organizations that scientists are all members of, and they all have position papers. I mean, the National Geological Society has a position paper on a position statement on the climate. They all have statements that you can go on their websites. It's a few key clicks away and find out what NASA scientists actually say about the climate, what NOAA says, National Academy of Sciences. And then you've got the IPCC. But then the people who are going to be the most skeptical of messages about science are going to see, oh, the IPCC is, it's part of the UN, and we already don't trust the UN, even though that is probably the most concentrated repository of data on climate in the world. But that's where if you want to know the opinion of scientists, to me, you don't need any intermediaries. You can go straight to the source.
Sure, if you don't trust this agency, you don't believe that agency. I mean, the whole point of science is that it's reproducible. So if anyone wanted, you can go online and download data. You can download decades of data and look at these trends yourself.
Right.
There are so many independent ways that we've been able to demonstrate what's happening. But if someone isn't open to new information and isn't open to the possibility of being wrong, then that doesn't really leave a lot of room for conversation.
Right. And I guess it comes back to the original question, the original point. What is it about us that we are so unwilling or unable to trust the words of scientists, that we leave ourselves open to people telling us what science does know and doesn't know, and what it means and what it doesn't mean? Why are we so skeptical about science if we're not in it ourselves? I mean, I guess that's what it comes down to for me. What is it about us? It's in our brains. Our ability to do science is in every single one of our brains. We've been scientists for tens of thousands of years. I mean, to figure out how to cook an acorn and not have it kill you took science. It took peer review. We've always been scientific. So why it's so frustrating to me that we are not able to just be our internal scientists that we are.
There's this phenomenon that that you learn in first aid courses, where if there's an accident and someone and an ambulance needs to be called, oftentimes if there's a whole crowd there can be scenarios where there's a whole crowd of people and not a single person will call an ambulance. Whereas if there's only one observer, the likelihood that one observer is going to call an ambulance is so much higher. But when you have a whole bunch of people, there is this tendency to rely on someone else, to assume that someone else has already done it.
Okay.
Someone else has already taken care of the problem. The reason I'm thinking about that is that in the context of, climate and solving these really dire global scenarios, it is, on the one hand, really kind of scary to think about and to really accept the reality of what's happening. So on the one hand, there's, an aversion to accept that. But then on the other hand, there's also a strong desire. There's a comfort in thinking that someone else is going to deal with this and just fix this problem and I don't have to worry about it. So, that makes it a lot harder. Right.
And I guess that kind of gets back to my point that we just want scientists to fix stuff, and that's supposed to be their job. Like, so if you're so smart and then you're looking at all this data and you know what it's supposed to be, like, you're supposed to, why isn't there a scientific, I think it comes down to a lot of that sometimes, is that there should be a scientific fix for this. You guys fix everything else. So, you guys need to just work harder on a decarbonizing, technology that can be scaled up on the global level so that we can go back to, watching sports and shopping and everything else that we do. We're not used to having to engage the question in order to solve the problem. It's supposed to be other people who solve it. We elect politicians to solve problems. We have scientists out there, learning about things furiously and creating new technologies based on that solve our problems. And I think we're not used to having to engage it.
Sure. Well, especially when, there are a lot of echo chambers that are conveying the idea that there's no problem to solve in the first place.
That doesn't help. I want to switch gears for a minute. Evolutionary biology is a big part of what you study. What do you say to someone who doesn't believe in evolution? Do you ever come across?
I don't, or at least if I do, I don't know about it, because that isn't, when I'm meeting someone new, that isn't
Well,
what I usually ask
right.
after what it's mean. So I don't really have this conversation often at all, although I would frankly like to.
What would you say to someone who doesn't believe in evolution, who says it's only a theory? Someone who looks at a chimpanzee and they look at themselves and they're like, nope.
Well, I would say, to the comment that evolution is only a theory, I would say, well, no, evolution is fact. We can see evolution happening. I mean, the latest, very relevant, not the latest example, but a very relevant example is with COVID-19 and the evolution of these vaccine-resistant strains. Evolution is much more than a theory. And it's true that there are aspects of how evolution works that scientists continue to debate and study.
But that goes to the mechanics of how evolution works. It doesn't go to the fact that evolution is happening, the fact that natural selection is a real thing, that adaptation and mutations are a real thing.
Oh, absolutely. There is no debate in the scientific community that evolution is a real phenomenon. There is extensive study and debate as to the mechanics and the details of how it works in different scenarios and the, genomic processes at play in various contexts. So the puzzle is very much still being put together, and that will probably always be the case, because every time you solve a problem and answer a question, that leads to more questions. But the fact that it is an ongoing area of study does not at all mean that there is debate about whether or not evolution is real.
Right, for sure. So you and I have talked before about education of science. A lot of the grants that you as a scientist would apply for have a requirement that some of that money goes to educational outreach to the public. Has that been the case with some of the grants that you've received?
Sure. It's, broader impacts that can take many different forms. That could be in the form of education. It could also be, it could mean a bunch of different things, but the general idea is that it will benefit society in some way.
So what does that look like? Like in real terms, what are some of those outreaches or those elements of grant research? What does it look like?
Well, it can look like a whole bunch of different things. It can be things like putting together, after school programs, or going to work with, like doing presentations in local schools. It can mean, like one really common thing is in a grant to ask for funding to hire, an assistant that you can hire, and give research opportunities to students, or, prospective interns, things like that. The options are really limitless. It can mean so many different things.
Are they mostly up to you as the researcher?
Well, yeah. So in that kind of it depends on the context, but yeah. So in that kind of a context, if I'm working on a grant application, I would think about the specific research. The best, what kind of approach makes sense will really depend on the nature of the research and the context in which that research is taking place.
Sure. When I think back about the science that you learn at school, you go in the lab and you do experiments. And it's individual experiments. It's all very basic stuff. It's like early scientific inquiries. And when you go out in the field and you look at what real science is doing, it's so different from that. I see a difference in language between a study or research as opposed to an experiment. But in school, you learn about experiments. Like in the 1600s, we did a lot of experiments, right? We were trying to understand basic concepts. So we were dropping things and we were smashing things and we were cutting things open and seeing what was inside of them. Like those to me are experiments. But you're not really experimenting anymore. You're doing studies. To me, the connotation of that is very, very granular. Like, does that make any sense?
It does. I would actually disagree with that. I still very much, think about the work that I do and, through a lens of, experiments. And, and to be honest with you, the way that I jokingly describe the field of ecology is, it really sort of boils down to, ooh, what is this thing and what happens when I poke it? I mean, obviously when I'm writing up papers and stuff, there's, all of this theory and, polish it up and everything, but it's really the, art of figuring out how things work and what are the consequences of changing the system. And I think that, at least in my opinion, the biggest gulf between, a student in, middle school or high school, learning science versus the actual discipline is that courses, teach information, and students might do an experiment to see, okay, we've done this experiment and shown that X leads to Y. But the emphasis, at least in, my experience, was very much on, the knowledge as opposed to the scientific process. And, of course, knowledge matters, facts matter, but science really, what it boils down to is the process of having you make an observation, you have an idea, test this idea, it never works the first time or the second time or what have you. And it's this iterative process of trying to, hone in on an answer to that original question.
Well, this has been a lot of fun. Thank you very much for being here.
Oh, my pleasure. Thanks for having me.
Thanks for watching. To catch the newest episodes, please support the Lizard Brain Project by subscribing. Lizard Brain. Question everything.